Everyone knows the internet is built on web servers, from big platforms like YouTube or Instagram to random APIs all the way to your crappy website written in React. All of them use web servers to handle requests and provide the data for the user. But I was wondering, how exactly does such a web server work? So I thought, why not build one myself? But before we can build a web server, we need to get a clear idea of what it should be able to do. Let's think about it like this. When you open your browser and type in a website address, something like youtube.com, what actually happens here? Your browser on your computer sends a message across the internet. This message is basically saying, YouTube, give me your homepage. Now, somewhere out there, there's a specific computer that is youtube.com. On that computer, there's a program constantly running, just waiting for these kind of messages. That program is the web server. Once the web server receives your browser's message, its job is to understand what you're asking for. In this case, we're asking for the homepage, so it then goes and finds all the pieces that make up the homepage. Once it has found everything, it sends it back across the internet to your browser. Your browser then takes all those pieces and puts them together, displaying the YouTube homepage. So simply put, our web server will be a program that listens for requests from web browsers, finds the right files or information, and sends them back so the browser can show them to you. That's the core job. Now let's start building. A quick disclaimer, I will program this web server using Golang. However, I am just starting out with Go. So later when you see my code, you're going to think that it's pretty, good looking, and following all best practices. Any other opinion is treated as a direct insult to my mother. Let's get started. Let's just start with the basics. At first, our server needs to listen to incoming requests and handle them in some way. So let's just do that. We will program the server in its own server package, which is also its own file. I am importing the packages fmt, io, and log for basic usage. The important package here is net/http, because this package will help us handle all the HTTP related stuff. In the start server function, we create a new serve mux. This mux is responsible for defining the different handlers for the specific routes. For the default route, for example, which is indicated by a simple slash, I created the default handler. Any function passed to the mux that has the same signature as this default handler, meaning it takes a response writer and the request as arguments, is considered a valid handler for the mux. We then pass this serve mux as a handler to the listen and serve function, where we specify that the server listens on localhost port 8080. For the default handler, we currently only log out information from the request and write the message hello world back in the response writer. In the main package of the application, which is in the file main.go, we simply import the server and call its start server function. To test this, we can go into the terminal and write go run main.go. We see the message that the server is listening on port 8080. And if we go to this location in the browser, we see both the request specific logs in the terminal and the message hello world appear in the browser window. Note here that according to the logs, the client made two GET requests. The first one is the initial call, which happened when we pressed enter after entering the URL. And the second one is asking for the fav icon of the website, which would be displayed at the browser tab if we had implemented it. Alright, that's cool and all, but now, because we only implemented a single default route, no matter what path we put after our domain, we always use the default handler and see the hello world message in the browser. We could add a new handler to our mux that handles a different route. Let's just do that real quick. We add a handler for the path foo, which just writes back foo. If we now go back to the browser and type /foo in the URL, we can see that the hello world is replaced by foo. Nice. Foo. But to be honest, manually adding routes to the server just to serve some static content is a little bit annoying. Instead, I want to introduce some type of file-based routing. That means instead of manually defining each route, the handler looks into the requested path and based on that returns static content. To do that, I added a website folder with a pages folder inside. Inside the pages folder is a standard index.html file. To route to that file, I changed the code inside the server a little bit. We now have only one handler inside the serve mux, which I simply called router. At the bottom of the router, I added some code to dynamically construct the file path. This file path joins the path to the pages folder with the path from the request URL made by the client. I then just call the serve file function from the HTTP package. This function takes in the response writer, the request and the file path and serves the file found in that location by writing it to the response writer. Let's test this by starting the server again, and in the browser we enter localhost 8080/index.html. You can see that the server correctly responds with the index.html file. Note, however, how the URL in the browser changed to the default route. That is because the serve file function that we used automatically redirects every call to an index file to the same location excluding the index, to make the URL in the browser look pretty. That also means that the serve file function automatically looks for an index if the path to the file only points to a folder. That is why I can refresh the page here and still see the HTML file. For any other route, however, it would not work and the serve file function correctly responds with a not found response. Also good to know, the serve file function automatically detects the file that it reads and sets the response headers correctly, which means we don't really have to do anything here. Let's make this a bit more structured. To separate HTML from CSS and JavaScript and images, I added 3 more subfolders to the website folder: images, script and styles. To make that work, I changed the code a little bit. Before building the file path and serving it, I create a target subfolder string. Its value depends on the extension of the requested URL path. For HTML files, it will be the pages subfolder. For CSS files, the styles subfolder. For all kinds of images, it will be the images folder. And for JavaScript files, it's the script folder. And of course, if no extension is provided, it'll default to the pages folder again. The file path is then constructed of website, the target subfolder, and the URL path of the request. To test this, I added a fav icon to the images folder because, like I said before, the browser always requests this. For our HTML file, I added some style in form of a CSS file, which is located in the styles folder. I totally just GPT'd that. Just kidding, I think I Gemini'd it. But anyway, for JavaScript, I added a script with just this function. This script is located in the scripts folder and linked to the index.html, which uses it when the button here is clicked. If we now start the server and navigate to the page in the browser, you can see that 4 total requests to the server are being made. One for the initial page, one for the style.css, one for the script, and one for the fav icon. As you can see, the page is now properly styled, and if I click the button, we see the alert message, which means the script also loaded successfully. Nice. Let's make all of this a little bit more robust by adding some error handling. So after we constructed the file path based on the extension and before serving it back to the client, we first of all check if the file exists. We call os.stat for that. This function usually returns some information about the file, but here we are only interested in the error. If an error happens and this error is of type not exists, we call the function handle not found and return afterwards. If that is not the case, but the error is still not null, because maybe we had not the rights to see the file, we call the function handle internal server error and then return again. If both is not the case, we simply proceed with serving the file. Handle not found and handle internal server error are both pretty straightforward. They just set the appropriate response header, either not found or internal server error, and then serve an error page. These error pages are located in the error subfolder in the pages folder, which I created for this case. Let's test this out. As you can see, reloading the page still works, and if we write something like lol.html in the URL, we get the 404 page. Nice. Okay, now that routing works and we have some error handling, let's talk about session logic. If a server wants to have some information about the clients that are calling it, it needs to save that information by himself in a session. Typical information inside a session could be if a client is logged in, when the session was last updated, and if he is authorized to visit a certain page. I implemented something like this in a really simple way. First of all, I added this session struct right here. Each session holds information about the last connection time and if it is authorized or not. I added a function to update the last connection time and a function to create a new session. These sessions will be managed by the session manager, which I also created. A session manager has a session map where each session is mapped to a string, which will hold the IP address of the connected client. Additionally, we have a mutex, because HTTP listen and serve works with Go routines for handling multiple requests at the same time, so we need a way to log the session map when reading from it later. Last but not least, we have the session expiration, which indicates how long a session is active. The new session manager function takes in the duration for the session expiration and creates a new session manager. The function getSession uses the remote address from the client and tries to get the IP address out of it. We then lock and unlock the mutex and in between check if the session map from the manager already contains this IP address. If so, we return it. If not, we create a new session, add it to the session map and return that one. The function isSessionExpired checks if a session exceeds the max expiration time from the session manager. To actually use this logic, I added a global session manager to the server package and created it in the start server function with a max expiration time of 30 seconds. That would probably be way higher in the real world, but for testing purposes it's fine. Inside the router function, I get the current session by providing the remote address from the request. I then add two checks. I decided that each request that wants to access a page that lies in the closed subfolder inside the pages folder needs to be authorized, and each request that wants to access a page in the expirable subfolder inside the pages folder needs to have an active session. At the end of the function, when a request was successful, I update the last connection time of the session. Again, this logic is just an example of how something like this could work. In the real world, the logic is probably more strict. Oh, and by the way, I also refactored the code for serving the error pages because I always got this warning here, which happened because I manually wrote the status code of the error in the response writer and then called file serve or serve file. Apparently that is not best practice, so instead I created a function where I manually read the error page file, set the correct content type in the header and write the content back to the response writer. Because we are now checking if the session is authorized or expired, I also added two new functions to handle these kind of errors. And yeah, now it works. Let's test the session logic now. When starting the server, you can see that we can still just call the default route, because it is not inside the closed or expirable subfolder. You also see that a new session was being created. If I now try to access the test.html file in the closed subfolder, I can see this unauthorized file, which is expected because although we have a session, we nowhere in the code set the authorized flag of this session to be true. Let's now try and call the test.html file in the expirable subfolder. As you can see, we get access because the session is still active. But if we wait for 30 seconds and try it again, the session is now expired. Nice. As last step for this small web server, I want to make it possible to add custom routes from outside the web server, like in a web application. Because currently all the web server does is serve static files with a little bit of session logic. All other kind of dynamic requests like AJAX calls with JSON returns are not possible. To make it possible, I added this custom route struct and this custom handler type. The custom route specifies what path it should handle with its handler, and you can additionally set those two Boolean values to make sure the server checks the session information before calling the custom handler. This handler uses the response writer, the request and the session. Once the custom handler of the route is called, it is his job to return a valid response. To save those custom routes, I added this global custom route slice inside the server package. The start server function now takes in a slice of custom routes and uses them to set the global custom routes. In the router function, before going through our original logic, I just loop through the custom routes and check if it finds one that matches the path of the request URL. If so, I first check for authorized and expired if needed, and then call the handler of the route, passing in the response writer, the request and the current session, and afterwards I return. To test this, I created this custom route in the main package. The handler here just changes the authorized state of the session and returns the string right here. The custom route will trigger on the path custom/authorize, and I don't want it to be expirable or need authorization. Let's test this. After starting the server, the main pages work just like before. When I now try to access the test.html file in the closed section, I am still not authorized, just like before. But if I open a new tab and enter our new custom URL, as expected, I just get the message now authorized. But when I now go back to the closed page, I can actually see the content because the session is now authorized. Alright guys, that's it. We successfully built a little web server using Go. I hope it is clear that I did not attempt to build a production-ready web server in this video. I was just trying to play around a little bit with the HTTP protocol and learn the Go language along the way. Anyway, I really hope you liked the video. If so, then please drop a like and subscribe to the channel to not miss out on any further videos. You can find the code from this video on my GitHub, which is linked down below, and feel free to leave some feedback in the comments. That's all being said, and I see you in the next one. Goodbye.